These notes are on graphing two-variable absolute value functions. And we're going to look at, we can talk about two-variable absolute value functions as a graph, as an absolute value function, or as a piecewise function. So we're going to go all three ways. Give the graph, go to the piecewise and the absolute value, give the absolute value, go to the graph and the piecewise, etc. So the first example is we start with a graph. Now, I find it easiest to begin with my, no, actually, I don't know that I find the easiest to begin with the absolute value or the piecewise. I'll begin with the absolute value. So we'll call this function f of x. And what you've learned in class is that absolute value functions can be written as some constant times absolute value minus x plus k, where the vertex, just like in a parabola, it has a bottom or a top, is h comma k, and a acts as the slope. But I'm going to put that in quotations because it acts as both a positive and a negative slope, which is the part that makes it the absolute value. It flips it up or down. So f of x. So my vertex here is at positive 4, negative 3. And my slope here is up 1 over 1, up 1 over 1. So my slope is 1. So when I write that as absolute value, I have 1 absolute value x minus 4 minus 3. And if I want to write that nice and clean, I can simply remove the 1 in the front. So we'll label this piecewise. Oh, excuse me, absolute value. Now for my piecewise, one thing that's nice about the piecewise here is that the vertex plays a very nice role. And actually, the vertex plays my point in my slope point form. So again, my slope is 1 for this first half, and my point is x minus 4 minus 3. That's the same point for my second, for the left-hand side, but my slope on my left-hand side is negative 1. And now I have to write my subdomains. So my turning point here is where x is 4. And I have a right-hand side and a left-hand side. So the first equation I wrote here was my right-hand side. It doesn't have to be. You could have written the left-hand side first. Depends on how you sort of see the graph. But on my left-hand side, I'm going to include 4 and say it goes to positive infinity. On my left-hand side, it comes from negative infinity, and it goes until 4. Now here's one of the important pieces here. This 4 is included in the function, but I can't have it included in both sub-functions because then it doesn't make it a function anymore. So I have to choose. I chose to include it in the positive side of the absolute value equation. So I'm not going to include it in the negative side. But you could have used brackets, parentheses here, and brackets here. Just to note, you could also write this as x is greater than or equal to 4 and x is less than 4. You don't have to use interval notation. You can use set notation, but make sure that you're using the notation specified by your teacher. The second example, we're given an absolute value function in this case. We're asked to graph it and write it as a piecewise. So I'm going to graph it first. I think I find that to be that's where my brain sort of gravitates towards. So I look at this and I see my vertex is at negative 3, negative 5. I can see that my slope is positive, so going to the right-hand side, I'm going up 1 over 2, up 1 over 2, up 1 over 2, etc. To my left-hand side, I'd be going up 1, left 2, up 1, left 2, up 1, left 2. Connect those. There's my graph. The way I remember two things. One, this function, because the a is positive, it's going to face upwards. The other is that I treat this slope as exactly written as the right-hand side slope. And for the left-hand side slope, I change the sign. So now for my piecewise. Call it f of x. I've got two pieces. One piece is what's written. It's the slope point form, slope with the point being the vertex. The other side is the negative of that slope. And now I have to worry about the domain, the subdomains. So again, my graph is cut in half by the vertex. And on the side where the slope is positive, I'm going from -3 to infinity. And on the right-hand side, I'm coming from -infinity and going to -3. You'll notice here that I switched my brackets and parentheses from the first example because I can. As long as one of these has a brackets and the other is parentheses, I'm fine. And then, of course, I could also write this as in set notation. So just to be aware that those two different notations exist. My last example is when they give me the piecewise and I'm asked to write the absolute value. So I'm going to graph it first. In this case, the point that I'm graphing is +1, -3. So +1, -3. And I'm going to look just briefly. It looks like, oh, there's a small typo here. Apologize for that. That should be +1. It looks like my boundary is at 1, which makes sense. That's where my vertex is, or my point in this case. They gave it to me in that form, which they'll often do. And it looks like for the first half of my function that that this is actually the left-hand side, that I'm going smaller than or equal to -1, that I'm coming from -infinity. And so I have a positive slope for that portion. So a positive slope of 2 looks like this. Where for the second portion, where I'm starting at 1 and going positive, I have a negative slope. The most common mistake you'll make here is to make this absolute value function a positive absolute value function. And so it's really important to see which of these subfunctions is the left-hand side or the right-hand side. So which is going from the -infinity and which is going to the positive infinity. So now I have my absolute value function. F of x equals, so the slope is 2, but we know that because this is an absolute value function that faces down, the slope is a negative. I have my vertex here is at 1, -3, so that's x minus 1 minus 3. And there's my absolute value function.